So in this video, we will be talking about the trigonometric identities. So these identities are basically things that you have probably seen already. So I'm giving them here, and you can access this PDF on Canvas. So you can go ahead and look at them. So you can kind of see that you've already know the quotient, reciprocal, and Pythagorean identities. So those are the ones that are used the most. You also have the even and odd identities, which basically tells you about whether a function is even or odd. Notice that the sine function in this case is an odd function because the negative is going to go on the outside. The cosine, the negative, goes away because it's an even function. You can fold it about the y-axis. You also have the cofunction identities. So basically, if I move one of the trigonometric functions by pi over 2 and kind of flip it around the x-axis, then you get another trig function. So see, sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Cosecant and secant are both also cofunctions as well. So, and that shouldn't be coming as a surprise because if you look at the graphs, you can kind of just flip them and you can see that they're actually the same. Then you have some other identities, the sum and difference identities. So basically, if you have the addition between two angles, you can just use this formula to try to figure out what that addition of two angles is. You have the double angle identities. So the double angle identities, basically if you have an angle that's multiplied by a factor of 2, you can actually simplify them. Notice that cosine actually has 3 different kinds, so you can choose whichever you'd like. They're all going to be the same. Then you have something called the half angle identities. These identities on this side are based. These guys actually, I like to call them the reduction identities. So reduction. Oops. Okay, so reduction identities, because you're basically reducing the square to something that doesn't have a square. Okay. And then over here you have these are what we call the half angle identities. I like calling them the half angle. You can kind of see that these identities are actually the same. If I just take a square root to both sides, you get the plus or minus, and you get the inside the same. The only thing that's different is that this is theta and this is 2 theta. Well, imagine that if I divide this theta by 2, well, I'm also dividing this theta by 2. So that's how I get that theta and this theta over 2. So I wrote them down here. So if you have this this thing, you can print it out for yourself, and then you can just put them in on a piece of paper. Don't worry about these two. They exist, but we're not going to really talk about them. So they might come up, but I mean, just keep them in mind. I mean, that you can rewrite a product of two trig functions as the sum of two trig functions, and vice versa. But usually the other ones I would say that are probably the most important ones. This one's also important, but you can just, I don't know. There's already a lot of identities. I want to look at the other ones instead. So what I really want to do is do a couple of the problems. So the ones that I really want to focus on, obviously this one. You know, these are really, really good. This one's I don't really care so much. So I'm just gonna put like a little baby star, as in like they're important, but and so you think with the cofunctions, they're important as well. But the ones that I really want to focus on is these 3: the sum and difference, the double angle, and the half angle. So this one, and then this one. So everything that has a big star are really, really really important. Everything that has a little star, they're okay. I mean, you can know that they exist. But the ones that I'm really going to do problems with are sum and difference, double angle, and half angle. So we'll do a couple of problems first. So we're going to start off with the sum and difference formulas. Okay. So starting with the sum and difference. Okay, let me go back to my notes. So we're going to start with sum and difference. Okay, and let me go ahead and just write the formulas down. They are. I wrote them down so that you don't have to watch me painfully write them out. So basically all I just did was I rewrote what's in here. Notice that there's plus or minus. Basically the plus goes with the plus and then the minus with the minus, but then they swap with the cosines. Okay, same thing with the tangents, at least the denominator does. Okay, so if you ever are interested of where these formulas come from, I'm gonna be posting the link to my trig videos, and you can see how I derive the cosine one. It's a little bit of a messy proof, but you can go ahead and just derive it, or you may haven't already have derived this formula before. So maybe you have in the past when you trig. So the first thing that I want to do, I want to show you an application of where exactly this is working. So why do we really care about the sum and difference formulas? So there's certain values that are not in the unit circle. So for example, sine of 15 degrees is not in the unit circle. So one of the things that we can do is we can use the sum and difference formulas to try to figure out what that is. Now, usually what we have to think about is, okay, how can I find two angles that I already know that will add up or subtract to get me 15? So we know all the values from the unit circle. So how can I use these two values or two angles that will give me a sum or a difference of 15 degrees? So what I like to do is I like to look at the first quadrant. I like looking at that and trying to see, do any of the combinations kind of work? And you'll see that if I take 15 and subtract 30, I'm going to get 15 degrees. So that's what I'm going to use. So I know that I can write this as sine of 45 degrees minus 30 degrees. Okay, so notice here that that's going to give me sine of 15 degrees. Okay, so then I'm just going to use the formula, this guy, all right, just apply it. So this is going to be the sine of 45 degrees, the cosine of 30 degrees, minus the cosine of 45 degrees, and then the sine of 30 degrees. So if I evaluate that, I'm going to get the sine of 15 degrees. So the sine of 45 degrees is just square root of 2 over 2. The cosine of 30 degrees, that one is just going to give me square root of 3 over 2. The cosine of 45 degrees, that's going to give me square root of 2 over 2. And the sine of 30 degrees is going to give me 1/2. So when I do this, I'm going to get the square root of 6 over 4 minus the square root of 2 over 4. And that's just going to give me square root of 6 minus square root of 2 divided by 4. So this is the exact answer for sine of 15 degrees. So if I were to give this in the exam, I would want the exact answer, not the approximate answer, because then I'll know that you just put it in the calculator. So I would want this to happen for you to do this as well. So same thing you can do, like for example, you can do it the same thing with radians. So if I did sine of pi over 12, this one's going to be a little bit more tricky because now you have to kind of figure out what two fractions will subtract to get pi over 12, so that the fractions now involve a common denominator. So you can easily see that all of these can go into 12. You just have to be able to figure out, okay, which one will give me that. So you can use your calculator there to try to figure it out. If you were to look at maybe pi over 4 minus pi over 6, right, you will see that if I take this, 12 and 12, this would give me 3 pi, this will give me a 2 pi. You will see that this is pi over 12. So if I choose these two angles, then I can rewrite this as the sine of pi over 4 minus pi over 6. And then you can just use the sine of sum and difference formulas again. And you can do the same thing with many other different angles. You just have to be very strategic about it. Okay? All right, so let me go ahead and just do another different type of problem. Okay. Here we have, suppose that sine alpha equals 3/5, and alpha here is between 0 and pi over 2, and cosine beta is equal to negative 5 over 3, and beta is between pi and 3 pi over 2. So here we want to find sine alpha plus beta, cosine alpha plus beta, and tangent alpha plus beta. So first, what we kind of need to figure out is where exactly does this alpha lie in, and where exactly does this beta lie in. So if we kind of look at two different things, so we're going to look at alpha and beta. Here's alpha, and here's beta. Let's see where exactly they live. So if you remember the quadrantal angles, this is 0, pi over 2, pi, 3 pi over 2, and then 2 pi. To complete one full revolution. So if you remember about sine, Sine alpha, we know that that's going to be the opposite over the hypotenuse, but we need to draw a triangle. So here we know that alpha lives between 0 and pi over 2, which is right here. So the triangle is going to look like this. So here is alpha. Okay, so now what we got to do is we got to figure out what exactly are going to be these points. So sine alpha is 3 over 5, so this is going to be 3 and 5. Let's just figure out the other side. So that's just going to be a squared plus b squared equals c squared. Get a squared plus 9 equals 25. Get a squared equals 16, so a is going to be equal to 4. And notice that it's going to be a positive 4 because we're in the first quadrant. And now what we're going to do is we're going to try to figure out where beta is. So beta in this case, if I do the same thing, 0, pi over 2, pi, 3 pi over 2, and then 2 pi, then what's going to happen is that beta is going to be between pi and 3 pi over 2. So here's pi, here's 3 pi over 2, so it's going to be in quadrant 3. So my triangle is going to be hinged around this axis. Beta is right here. And now beta is going to be, cosine beta is negative 5 over 13. So that's going to be the adjacent over the hypotenuse. Notice that in this case, it will make sense for the 5 to be negative because it is on the negative x-axis. So now let's try to figure out the other guy. So it's going to be negative 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. B squared equals 100, no, that's going to be 144. When I take the square root, you're going to get the plus or minus 12. So notice that in this case, since this is in the negative y-axis, this should be negative 12. So the one that we're going to get is a negative sign. All right. So now that we kind of have the triangles, we can kind of do the problem now. So now all we have to do is write down the formula. So we want to find all of these three different guys. So what would they be? Let's sine, we will have sine, and then here we want alpha plus beta. So we know that that's going to be sine alpha cosine beta plus cosine alpha sine beta. So they kind of alternate. All right. So now let's figure this out. So what is sine alpha? So sine alpha, we look at this triangle. That's going to be the opposite of the hypotenuse. That's 3/5. Cosine beta. Cosine beta, now we're going to look here. Cosine beta is going to be this negative 5 over 13 plus cosine alpha. So this cosine alpha, we're going to go here. That's going to be 4 over 5. And then sine beta. Sine beta is just going to be negative 12 over 13. Okay. All right. So now this guy is going to give me negative 15 over 65. This is going to give me negative 48 over 65. Which is going to give me negative 63 over 65. Okay, so that's that one. All right, now can we figure out what cosine alpha plus beta is? So cosine alpha plus beta is just going to be the cosine alpha, the cosine beta, minus sine alpha, sine beta. All right, so cosine alpha is just going to be 4 over 5. Cosine beta is going to be negative 5 over 13. Minus sine alpha, that's going to be 3 over 5. And then sine beta, that's going to be negative 12 over 13. So now this is just going to give me, what is this? Negative 20 over 65. Then a positive 36 over 65. Which is going to give me just 16 over 65. Okay, so that's the cosine of alpha plus beta. And now finally, we're just going to do tangent. Okay, so tangent alpha plus beta is going to be tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha, tangent of beta. Okay, so now let's look at the tangent. So tangent of alpha is going to be equal to 3/4. tangent of beta, that's going to be 12 over 5. Then you're going to have 1 minus tangent of alpha, which is 3/4. Tangent of beta is going to be 12 over 5. Okay, so let's just put this into our calculator. On the top part, what I get is 63 over 20. And on the bottom one, I get negative 4 over 5. So when I multiply this out, what am I going to get? Negative 63 over 16. Okay, and that's basically going to be your answer. Now, alternatively, what you could have done is that you could have divided the sine over the cosine of this guy, and you would have gotten tangent instead of doing all this formula. So that's another way that you could have done it. Okay, so we're going to finish up this section with just one more problem. Finish it up with this problem with sine of cosine inverse of 1/2 plus sine inverse of 3/5. Okay, so kind of combining both inverses and the sum and difference. So one of the things that we've kind of did in the previous video with inverses is that whenever I see an inverse inside of something, I can just give it an angle. So let's say I'm going to give this guy just alpha and then beta. I could have also said that's going to be theta and phi. It doesn't really matter. So right now I said that alpha equals cosine inverse of 1/2. And then the other one is beta is equal to sine inverse of 3/5. So that's kind of what I gave. So remember that I can always just multiply this or add a cosine to both sides. This goes away, so I'm left with cosine of alpha is equal to 1/2. And then for the other one, I can do the same thing. Take the sine to both sides. This goes away, and I'm left with the sine of beta is equal to 3/5. Okay? So now, based on that, I can kind of create a triangle. We don't know really where exactly these are, but I'm going to pretend that alpha and beta are both in quadrant 1. They're both positive, so I would imagine that this will be in quadrant 1. So, so for cosine alpha, we're just going to write the triangle. So here's alpha, okay? And cosine alpha, we know that it's adjacent over hypotenuse, okay? So then we're just going to do 1 squared plus b squared equals 2 squared. So we're going to have 1 plus b squared equals 4. So b is going to be equal to, what is the square root of 3? Okay, this is for alpha. And then for beta, so do another right triangle. Here is beta. And now beta in this case is going to be sine beta is 3 over 5. So that's going to be the opposite over the hypotenuse. So then the other one, we've already done this one, so the other one will be 4. Okay. All right, so now why would I do this? Because now what I can do is that I can substitute these guys. So sine alpha plus beta. Okay, so I kind of made these things that looked really weird to alpha and beta. So I can just use the identities. So sine alpha, cosine beta, plus cosine alpha, sine beta. I know sine alpha, okay, sine alpha that was given to us, that's going to be 3/5. No, that's wrong. Sine alpha is going to be right here. So sine alpha is going to be square root of 3 over 2. Cosine beta is going to be looking at the second triangle. That's going to be adjacent over hypotenuse. That's 4/5. Cosine alpha is now going to be 1/2. And sine beta, that's going to be 3/5. Okay, so I kind of know what all of that is. So we're going to have 4 square root of 3 over 10 plus 3 over 10. Combining this will give me 4 square root of 3 plus 3 over 10. Okay, so just a little trick. We are combining a little bit of the inverses with the sum and difference, but nothing too complex.